So hello and welcome everyone. I'm Amelia Bampton and I'm Regional Director for Codurance UK North, and I'm today's event facilitator. So thank you all for coming and joining us. In today's discussion, we'll be looking at how in recent times, organisations are now realising that there's a change in culture that's required to build securely and at speed, notably adopting DevSecOps, where we see security being baked in to the rapid release cycles that are now typical of modern application development and deployment. So in today's conversation, we're going to talk about the benefits of DevSecOps approach. And we're going to talk through a couple of slides with our speakers today. We're happy to take questions as we go, so I'm going to do my best to keep an eye on the chat. So if something's coming up for you, feel free to pop it in the chat box and I'll try and pick it up and answer it as soon as those come through. So at this point, I'd like to introduce our excellent speakers today who are experts in the industry. So that is fantastic. We have them with us tonight. We have Thomas from Snyk and we have Rodrigo joining us from Codurance. So we're going to take a minute now to meet the speakers. So Thomas, can you start and give us an introduction, please?
Sure thing, Amelia. Hello, everybody. Thank you for coming in. My name is Tomas Gonzalez. I'm a partner solutions architect at Snyk, and I focus on telling stories on how Snyk fits in with other tools and other partners in the ecosystem to enable DevSecOps as a part of digital transformation. Pleasure to be here.
Thank you. Perfect. Rodrigo, can you give us an introduction, please?
Sure. Thank you, Amelia. My name is Rodrigo Nascimento. I am the head of platform engineering for Codurance. I've been working on IT industry for around 30 years now, across different industries and, of course, different areas within IT itself. Most recently in what we call platform engineering. So at Codurance, we've been trying to use that as a holistic approach to help customers to make the most of the cloud resources and get their applications in a fast and efficient way to the cloud as soon as possible in a secure way. Thank you.
Fantastic. Well, thank you for joining us this evening. So Thomas, it'd be really great if we could hear a little bit more about Snyk.
Absolutely. So to kick it off, Snyk, we're all about helping companies develop fast and stay secure. We bring forth a technology and a platform that is not everything you need to do a digital transformation, as we'll talk about during this show, but it is a technological component of the people, process, and transformation. We got our start in 2015 doing open source security and license compliance. Since then, we've been through 5 rounds of funding. We have added more capabilities to our portfolio and our platform, and have just also exploded in terms of employee growth and developer adoption. We're used by over 2.2 million developers worldwide to keep applications secure. And that's a little bit about Snyk without too many spoilers for what we're going to show today.
Yeah, loads more to come. I've seen it and I'm excited to see it again. Fantastic. So it's probably suitable for me to talk a little bit about Codurance. So Codurance are a software consultancy. We're global. We've got 3 offices. So we have the London office, the Manchester office, and also our Barcelona office. And we are now over 100 people across those different locations. And there's a range of services that we deliver to our clients across numerous industries. And our key services are around software delivery, also software modernization. We're seeing particularly popular at the minute, and clients getting us in to help them modernize their tech stack so they can continue to kind of scale and grow and optimize. We also offer strategic advice and specialist expertise in a number of different areas. So that is us. In terms of the partnership and how we come to be here this evening for me, but many different types of the day for the rest of you. So Codurance and Snyk partnership, it enables businesses of any size to put security safely and successfully into the hands of the developers without slowing down the path to production. So we do this by helping our customers to build security first engineering practices and quality processes, plus the right tools such as Snyk as a platform to allow the early detection and fixing of the vulnerabilities in the code. So at this point, it's very exciting. We're going to open the conversation up and to deep dive into some of the topic areas that we've mentioned. There we go. So to kick this off, Thomas, can you discuss how the software delivery landscape for organizations is changing as they look to become more agile and adaptable?
Absolutely, Amelia. So this slide builds out almost as the processes have built out for organizations that have looked to become more agile and have adopted the cloud and have embraced, DevSecOps or DevOps in some form, if you will. So think about the time before the cloud, when there was a very divided line of responsibility between what development did, what operations did, and what security did. Everybody kind of worked in their own silo. Different pieces of the equation were owned by different teams. And particularly when deploying an application, developers would write code, they would pick open source components for their application. And then when they wanted to run it, they had to reach out to their IT admin, reach out to somebody in their organization, say, I need a server with this much memory, this many cores, this much storage, these firewall rules. And that sometimes could take time. We're talking about maybe months between the time a server was requested and it was provisioned. Fast forward to the cloud. I like to call the cloud the great enabler, or the great equalizer in this case. Developers now have a lot of the capability to provision their environment and provision the runtime of their application, not only the code in the open source they write, but this whole previously divided responsibility is now available as code with technologies such as containers, Kubernetes, Terraform, as well as other infrastructure providers. So what we have seen, the change is that developers that were previously required to be experts in writing code and picking good open source now have these other factors to consider as they're writing applications. They define their Docker files for their container images. They define their Terraform for their infrastructure. So now effectively, they have to be experts in more than just the writing of the applications, which has completely changed the dynamic because now, operations and security teams that were experts in doing their part of the equation now have to look at what developers are doing and think, are they doing it right? So it has definitely shifted a lot of the responsibility left, pun unintended.
Perfect.
Yeah, I completely agree with that. I think that's also motivated a lot of collaboration between these two areas. And one of the things that we're probably going to speak about that in the next few slides, but I think that's the fact that this kind of culture also introduced some more agile ways of doing things in terms of faster feedback to the developer, so he can start to shift left this kind of responsibilities. It also promote a little bit about experimentation. So as you can try things and fail faster, you don't need to wait for long periods to have a feedback about what you are trying to experiment with. And that, by consequence, I think it drove a lot of innovation through the companies as well. So I think that was an excellent outcome from this kind of culture that came with all this underlying technology.
Yeah,
Spot
I think
on, Rodrigo.
Yeah, it's so interesting, even from my own observations from my time delivering in tech, how things have changed, and how everything used to be so backloaded into the process. It's great to see those movements. So
yeah, it's funny. So just one more thing. It's funny because when you talk about containers, for example, you can see that the focus is moving more towards the application itself rather than the separation that you used to have before. So I think in terms of containers, you can see that the technology enabled a more like application-driven deployment and build of the environment as well. So you don't need to now you don't need to worry too much about the underlying layers that you usually used to in the past, like the servers and the operating system and things like that. And then it also collaborates into this maturity that we are reaching now in terms of caring more about the application, the services they're going to deliver to the end user, and not so much about what are the supporting services.
Fantastic. It's great to hear. Yes, it's great to hear all the changes going on in the space and the benefits they're bringing. So if we look now to move the slide forward. There we go. Something I know we wanted to talk about, Rodrigo, and again, with my project management background, cost and commercials are always really close to my heart. Talk to me about the financial impacts of some of the changes we've just spoken about there.
Yeah, the financial impact is, again, this is not new in terms of the cost, this exponential growth of the costs to fix the facts as we get closer to production environments, so that's where I think my previous point about the fast feedbacks is important, not only from the experimentation perspective, but from the cost saving perspective as well. As early you can catch these defects and you put the right gates in place, being that tests or security tests or whatever other mechanism that you put in place, will discover these defects at the beginning. The less is the cost of fixing those defects. And of course, that's as you move towards production, there are some these are the direct costs, right? So if you think about other indirect costs that can be related to when you find defects in production, you can also think about security problems that you may have that can damage your brand, or even some legal costs involved in terms of data breach and things like that. So I think that's really important for us to see here one of the drivers for the shift left as well.
Yeah, to add one thing from the developer's perspective too. Imagine as a developer, you write an application, you code it, you send it over, and you end up deploying it to production. If you don't quickly let the developer know that there's an issue in that application, that developer will have moved on to another project. They'll have started solving a different problem. And so to then reach out to the developer after the fact and tell them, hey, you remember that code you deployed 3 weeks ago? Yeah, we found an issue in it. That developer now has to stop what they're doing, reread their code, figure out what they were thinking. So it's the reputation cost. It's also the technical cost, but also the resource cost on the asset that actually has to fix the issue.
True.
And their productivity.
Yeah, it's so interesting. I might be giving my age away here, but I've definitely been on many an early morning production deployment where, you found that killer bug in production, you've had to roll back, all systems have been out during that time. And like Thomas was saying, that just the cost of the people alone that have been there for that deployment that has failed is immense, let alone some of the brand reputation and downtime and everything that comes with it. So yes, I only wish I'd been around when we'd been doing deployments another way to see the benefit. This is great. So let's talk now a little bit more around organizations implementing DevOps. We spoke about some of the benefits financially and from a business perspective, but are there any remaining concerns from the business view? Where might DevOps still not be enough?
Yeah, so I'll kick this one off, and then Rodrigo, feel free to add color. So where DevOps can be enough, think about, there has to be a shared interest and a shared agreement. Like if you tell the developers without direction, look at the results from this security tool and fix everything, then that developer is going to look at a huge backlog of vulnerabilities potentially and think, oh man, where do I start? Like, what do I have to do to get this application running back into production? So where shifting left is not enough, and I mean, this slide builds out once, is to actually, you need to build a culture where developers, security, and operations are all aligned on this concept of what are we willing to tolerate? What risks are we willing to tolerate in our environment? Like, to give an example that without spoiling too much what we're going to show later, is should we allow only medium and low severity defects? We don't want any higher critical severity defects. Well, what if there's no exploit available for those higher critical severity effects? Should we prioritize those lower? Right. So being able to come up with a common agreed upon, level of acceptable risk, where, to state an arbitrary example, we don't want any higher critical severity defects that have an exploit available that has been documented in the wild, right? That requires communication and collaboration between these previously siloed teams, and that comes with a big culture change.
Yeah, I completely agree. And then I also think that from the developer's perspective, in terms of empowering the developers, I think it's really important to think about how we're going to leverage these skills as well. There's a learning process, which is probably the first step, that they need to educate them on how to understand all these inputs that we're going to give them in terms of vulnerabilities and what to do with that. So maybe one of the key things to do to empower is, from the skills perspective, is some training, and of course give the right tools for them to implement the necessary mechanism to control security. And then it's really important that whatever process that you put in place to support consider two things. The first, as Thomas said, in terms of bring together security with dev and ops, because it can't be a separated silo at the end of the process. Okay, so there can't be a separated team, and then the name is DevSecOps and then not DevOps plus Sec. So it's really important to find a way, the same way that DevOps brought together developers and operations, you need to do the same with security. And at the end, and most importantly, but equally important, I would say, is to measure what's going on within your environment in terms of putting in place the right metrics and the right KPIs, so you can, at the end of the process, look at all this data that you generate in terms of the vulnerability, in terms of the criticality of the vulnerabilities, what actions that we're taking upon that, and put all this feedback in at the beginning of the process again, and do the same discussion. So this, maybe we have new vulnerability, maybe the way that we are acting with existing vulnerability is not so efficient anymore, maybe it is not so important, and is impacting the pace of your deployment pipeline and things like that. So it's really important. I think that Thomas made this point quite clear at the beginning, that you consider people, process, and technology when you try to implement these concepts.
Yeah, and there's been an interesting point in the chat from Flavia, which I can really resonate to. I think coming up from the conversation across this in the last slide about the problems don't change in tech. But what's great to see, and I think what's coming up in this conversation, is it's just how efficiently we kind of, and how fast we now fix and face into some of those problems, rather than, like I said before, everything seemed to creep quite back-ended and finding out things quite late in the process. So yeah, great point. So keep them coming through on the chat. So now I was keen to understand what are the main security problems and what's the impact they have? What are we talking about when we mention those things?
Sure. So I'll start this one, and then Rodrigo, feel free to add color as necessary. So from the point of view of the application, right? So I'm not going to outline every possible like security risk in a running environment, because again, it's divided. There used to be a division of responsibility. So let's talk about, I'm going to narrow this down to the application. So a developer writing a cloud native application really has 4 things to worry about, and maybe more, but 4 primary things. Number 1 is the code they write. This is the secret sauce of the applications written by many organizations. This is proprietary intellectual property that then glues together. So one more build out, please, Amelia.
Yep.
So that code is used to bring and glue together various open source components that will show up under the level of the iceberg. There it is. That this is so really the code that's written not only does it have to be free of security and quality defects, right? You don't want SQL injections, cross-site scripting, directory traversals. Like there's a lot of things that could go bad with the code, but also research has shown that as the cloud has exploded, so has the use of open source. And so a modern application might have something around 80 to 90% of its application using code that wasn't even written internally in-house. So the developer has to worry not only about the code that they write, but about the code that they're pulling like from the market. Does it have any vulnerabilities that have been disclosed? Is it compatible with our organization's license compliance policies? And this extends to the next build out. I'm going to try to smoothly insert the build out keys in there.
Thank you.
This extends to containers as well, right? Containers are a packaging exercise, if you will, on how an application can be packaged in a way that's environment agnostic. A container is a container, and an extension of the risks introduced by open source is that a container might also bring in potentially hundreds of packages in the form of Linux packages. So if you're using Linux containers, if you're using Windows containers, sure, those too. But this is more borrowed code that previously in the first diagram I showed, this was the responsibility of the IT and operations team to make sure that the running environment of the application was minimized, it was hardened, it was built properly. Now all a developer has to do is write a single from statement in their Docker file, and they can package an app into a container. And finally, like on top of the code, the open source, and the container, from the application's point of view, you have to think about how this application is going to be deployed into a running environment. This is the infrastructure that's defined as code. Technologies like Terraform, CloudFormation, Azure Resource Manager, Google's Deployment Manager. These are all ways to now spin up servers in minutes. What used to take months can now be done in a matter of minutes. And usually it's developers that are writing the Terraform files. They're the ones writing the CloudFormation templates. So how has the risk posture? This is an illustration of how that shift in responsibility, where before these bottom 2 layers might have been taken care of by a SecOps or an IT ops team. It's now part of the developer's responsibility to make sure that these components that are all part of the application, right, are secure.
Perfect.
I don't know if I can skip to this one, Rodrigo. I don't know if you wanted to add anything to that one, but
that's fine. I think that's
I can keep going.
Friends.
So
yeah,
just a couple of it.
Yeah, sorry, Thomas. There was just a couple of comments coming through. Let's have a little look what's coming through. Yeah, and so Flavia's also saying GitHub Dependabot. Did I say that right?
Yeah.
Dependabot.
Flavia knows.
Yeah.
Flavia knows.
And then I think a question coming through from Dan actually. How do we get started with DevSecOps if we haven't ever done it before? also, if we don't have a DevOps culture, would you recommend starting there or going straight into DevSecOps? Great question, Dan. I don't know who wants to go for that.
I can start.
Yeah, please do.
Yeah, I think there is no, I think, straight answer for that, because it really depends. It depends of the other things that you're doing in your organization, right? So if you think that you have the support first of the senior management to do this kind of a big transformation and support the implementation of a DevOps culture that can also bring security along with that, then yeah, definitely, I probably would say that starting with DevSecOps wouldn't add too much on the top of moving to a DevSecOps anyway. But again, it's just a matter of changing the mindset and seeing how you can change the culture of your organization to support those areas.
Yeah, I'll add, if you're just getting started on that journey, and this is just adding to what Rodrigo said, and you're starting to build these cross-functional units where you're now starting to drive alignment between development and operations. Like, it is great to include security in those conversations early, even if their influence doesn't manifest right away. There is an adoption curve to DevSecOps, right? You don't just want to introduce security in the beginning, but you also don't want to introduce it like later to the end. So have them, definitely invite them to be part of the conversation, and and work together with them. Just as Rodrigo said, it's just an extra stakeholder on the table. Yes, it will add more workload, but it will make things easier way down the line.
Yeah, thank you. Great stuff. Let us know, Dan, if there's anything else coming up in terms of questions for you. So we were going to talk now a bit more around open source. I can build this out a bit more.
Yes. So this is an extension, and Flavia made the comment, GitHub Dependabot, like Snyk and Dependabot address similar pains in that this is an extension of what I was talking about earlier. A lot of the code that is used in a modern application is not written in-house. So for example, you might have 80 lines of code across 3 files where you're introducing a certain set of dependencies for your application. These might be a requirements.txt file for a Python app, a package.json for a Node app, where you're saying, I need this HTTP module, I need this markdown module. Instead of writing the code for every bit of your application in-house, it's now super easy to just import code from the open source realm. But what are the implications of that? There's one build out here.
Yeah.
Is that those 3 files with 80 lines of code where you declared 7 dependencies introduced a whole other 59 dependencies of dependencies, for a total of 713,000 additional lines of code. Your application just got 1,000 times bigger. But as a developer, I didn't have to write all that functionality. So there's a beautiful side to this where organizations can now iterate and develop new functionality and add new things to their application. But the right controls have to be in place. Open source vulnerabilities are disclosed on a daily basis. Like, if you're using open source and you haven't updated your dependencies in a month, maybe in a week, there's a chance that a vulnerability has been disclosed for that application. So this is part of the risks of using open source.
Perfect. And just a bit of feedback from Dan, it seemed like that answered his question. So thank you for that. And Flavia is also raising some good points which were raised in there and been raised throughout. It's a cultural approach as well. I think we said at the start, it's the people, process and the tech, and it's winning the hearts and minds to be able to kind of utilize these changes. So some great conversations coming through there. And I know that in the next area, we're wanting to talk a bit more about the containers as part of the process.
Yeah, so this is an extension of the open source risks. Not really a whole lot to add here, but containers are being adopted. Like it's a reality, right? And many of the images, these are stats from our open source report. This has not changed, but like many of the images that are used, even if they're official images, even if they're vetted, like Linux packages have vulnerabilities disclosed for them too. And so for developers that are writing container images, there is a right way to do containers. Yes, you can start with a more secure base image. That's a fantastic way. You can use a multi-stage build to build your application with a container with more dependencies and run it in a slimmer image. Like these are good practices that aren't immediately clear to organizations that are getting started with their containerization journey. So it's an extension of the open source risk. Just where the application is, how it's being packaged, like needs to also be considered.
Yeah, perfect. And then the last discussion point before we go to the exciting demo that I've promised everyone at the start. So just to kind of, talk about how security can be introduced into the DevOps pipeline as a last bit of discussion before the demo.
Yeah, so without too many spoilers, this is what we're going to demonstrate today. Security does not have to come late in the cycle. The whole purpose of shifting left is introducing security early. That's why you see in the code stages the ability to test and fix vulnerabilities, the ability to test for vulnerabilities when the code is sitting in the source control repository, again, to test and maybe gate a pipeline from deploying an application if it contains any vulnerabilities. But then also when the application's running in production, you can still test it because, as I mentioned earlier, new open source vulnerabilities are disclosed every day. So to be able to, it is possible to integrate security throughout the life cycle. It's not just a one point in time as it used to be for organizations that were using waterfall methodologies. So we're going to see all of this in action today during the demonstration. Perfect. I don't know if Rodrigo wanted to add anything there before we go into the good stuff.
I think that this slide is quite important for people to visualize what we're going to demonstrate, what we're trying to prove here. And I think that's it's good to see that we have a kind of monitor and more at the beginning, because as I said before, what's important as well as part of this process is to capture the outcome of this security tests through the life cycle of that application, and then feedback at the beginning so we can do some improvements through the next cycle. So when we discuss that with the security team in terms of understanding how we're going to deal with some vulnerabilities and how we're going to build our policies, it's important that a security testing tool has this kind of features that can help us to visualize what's going on.
Yeah, great. So without further ado, we're just over halfway now, so I think we're there or thereabouts with the timing, so that's fantastic. I'm going to stop sharing and we are going to get into the demo.
Yay! All right. So a couple of things before we get started, I want to show you. So first off, I'm going to be using Visual Studio Code as the IDE for the demonstration. There's nothing in here yet. Our code is on GitHub. The Goof application that I'm going to be demonstrated is forked from Snyk's repository. So if you'd like to replay this demonstration on your own and play with this, you're more than welcome to. The code's open source. Do not run this in a production environment. Although it is a very harmless looking to-do application where you can keep track of things like buying milk, it is very vulnerable by design, because it's intended to demonstrate some of the risks in a modern application. So the code's on GitHub. We're going to be using CircleCI for our CI/CD pipeline. So this actually takes the code from GitHub when we commit to it, and it'll run a couple tests. We'll demonstrate what it's like to integrate security testing into the pipeline. There's a manual approval where the application is deployed to a cluster in DigitalOcean. So we're going to be praying to the demo gods that everything goes smoothly, and we'll be able to show you some cool things throughout this demonstration. So first off, I'm going to start with the Goof application in the GitHub repository. This is a Node.js application. So we have a combination of a couple things. We have the application itself, the app.js file. This is the custom code piece of the iceberg that I was demonstrating earlier. The package.json file, this is where our open source dependencies are declared, right? So this is the first layer under the iceberg. It's the open source components. The Docker file, which controls how this application is packaged into a container, going one layer deeper into the iceberg. And then we have manifest files. These are the YAML files that tell Kubernetes how to spin up and expose that container as an application. So these are the 4 bits of the application. I'm going to start our journey in Snyk. So the very first thing, after you sign up for Snyk, it's going to ask you, where is your code? Right? Where do you want to import? We have lots of different integrations that you can use. So depending on where your code lives, if it's GitHub, GitLab, Bitbucket, Azure repos, connect it directly to your source control system. And once it's connected in the projects tab, you'll be able to add project. In this case, it's a GitHub application. Find the repository from your GitHub account, in this case, Goof demo, and you add it. So that is the onboarding experience for an application in the Snyk using the source control integration. Once it's onboarded, Snyk is going to just break out the layers of the iceberg for us. So we have the vulnerabilities in our package.json file. We can see, again, Goof is very vulnerable. We have our Docker file, which introduces its own set of vulnerabilities, the YAML file, which introduces its own set of configuration risks. We'll dive into those in a little bit, as well as the code analysis. This is the toppest layer of the iceberg for the custom code. So let's start with a little bit of a demonstration of one of the invisible risks of using a vulnerable open source component. So our package.json, we have 82 issues. So again, it's a very vulnerable application. When I started at Snyk around 10 months ago, there were only 70 vulnerabilities or so for this application. So there have been, to the point of new vulnerabilities are disclosed every day. More vulnerabilities have been disclosed for the same application. And the one thing I was mentioning, to a point I was mentioning earlier, we're sorting vulnerabilities by what's called a priority score. Organizations a lot of times have a hard time figuring out, I have vulnerabilities, now what? So part of that exercise in building a common ground with different teams across the organization is figuring out, what is acceptable, what is not. And so through policies, which I'll demonstrate in a little bit, but also through these elements in the user interface, these are designed so that a security team, operations team, and the development team can come together and agree that, okay, the only thing we care about are critical severity vulnerabilities, for example, or vulnerabilities that are fixable, or vulnerabilities that have a mature exploit published. So, but you can also take Snyk's algorithm that has synthesized all these different factors into a single easy to consume score. So our priority score, pulls together, is there an exploit available? How long has the vulnerability been out in the wild? Is it being discussed in social media? Something that was recently added to our priority score. Is there a fix available? And synthesizes all these bits of information into one easy to consume score, which you can then use, maybe as you're getting started on your security journey, your security team and operations teams agreed, I don't want anything with a priority score higher than 800 as one of the metrics to control. So this is a slight visualization of how that agreement, that culture change can manifest within a security tool. And then the experience that a developer sees, let's say the developer knows and they're clear, I only need, to fix the things with a priority score of 800 greater. Here they can see, okay, this is the component that introduced it. Here's the component where the issue was fixed. If I need more information, I can read a small overview, or I can go to the vulnerability database and get more information about this vulnerability, including how it's exploited, And in a lot of cases, Snyk security team will actually write additional information that might help a developer construct an exploit. So they can test to see if their application is actually vulnerable to this vulnerability. So how does this translate into a developer experience? Well, first, I'm going to show you an example. The Goof application has many exploits available. My favorite one to show is a directory traversal vulnerability introduced by the package ST. It's not super highly rated on the priority score, but it's interesting to show because this is a vulnerability that can potentially leak the contents of the container file system. Like, just because you're running an application in a container is not automatically secure. So let's see what that looks like. So here's our harmless Goof to-do application one more time. I'm going to take the endpoint of this application, and I'm going to tear this down afterwards. So if you try to save this IP address and get into the application, it'll work now, but it won't work later. And if you decide to try this for yourself, let me make this bigger. Amelia, Rodrigo, is this a good size on the screen? Can you see it properly? I want to make sure our viewers can see it too. Beautiful. So I'm going to save the host of the Goof application. And like I said, there's a bunch of different exploits in here. In this case, the one that I want to show is the one from the ST package. So what this is doing, just so before I run it, is we're running a series of curl commands that, instead of, putting backslashes, we're using a different representation of the same symbol for the dot between the backslashes, which takes advantage of the exploit in the ST package. So if I source this file and then I start running these commands, it's like, okay, my application's responding as I expected. Oh no, now I'm starting to get information from what's running on the containers file system. Oh no, like I'm now starting to get more information back from the application. This is information that shouldn't be, it shouldn't be returning. And maybe if I'm crafty enough, I might be able to leak the contents of the password file in the etc directory in the containers file system. So these are part of the risks. Like, just a vulnerable open source component opened up a backdoor in my application for somebody to maybe leak contents from the containers file system. Like, the implications are pretty large here. So what is the developer experience here to fix this? Well, there's a couple ways. So we know that the vulnerable component was declared in the package.json file. So one of the ways to do this, you can use the Snyk IDE extension for Visual Studio Code, for example, and find the ST package. It has 4 vulnerabilities. Selecting the package right here can either give you more information about fixing the vulnerabilities or learning more about the vulnerabilities. In this case, see here are the same vulnerabilities that we saw within the Snyk user interface for the ST package. You can fix this by upgrading to ST version 1.2.2. So a couple of ways you can do this. You can either fix it right here, taking into account the remediation guidance offered by Snyk, save the file, it'll rescan for vulnerabilities. And this version might introduce more vulnerabilities. So what can we there? That's just the nature of open source. There might be new vulnerabilities in the upgraded version of the package. But if we look at this again, like, it still is thinking we have the old version of the package. So probably just have to regenerate our log file. But instead of doing all this, let's just have Snyk do it for us. So going back into Snyk, here's our vulnerability. I can tell Snyk to just open up a pull request. And what this is going to do is it's going to reach out to GitHub, check out a new branch against our repository, upgrade the package in the package.json file. So Dependabot was mentioned earlier. This is very similar to what Dependabot does. So yes, we can do what Dependabot does and more. And
Thomas,
what we're going to do is, yeah.
Oh, just a question coming up, just so we can pick them up as they come. So
Sure.
Dan's asked, is there a particular company size or industry, therefore, that DevSecOps would be most valuable for?
Oh, definitely. I think size, it's debatable, because we have a lot of fintech startups, which is quite small, and security is by nature one of the most important priorities that they have. And of course that industry, if you can get as more regulated is your industry, probably more secure. You need to keep your environment. I'm not sure if you have a different view, Thomas.
No, I just say any size company would really benefit. Most companies, if not all companies, are software companies nowadays. And software security is something that is top of mind for software companies. So if you have a smaller company, addressing and building this culture and building this practice early is only going to help you as you scale and grow.
Yeah.
If you're a large company, then you have more at stake, more to lose. So there is a benefit to adopting it there. But I would say any company can benefit from starting to think about this.
Thank you. And you're getting good feedback on the demo, Thomas. So yeah, Flavia was particularly happy to see Circle CI as part of this. So yeah, and dancers, thank you. So good stuff. Sorry to.
I'm glad you mentioned it.
Yeah.
A couple of things are happening on the Circle front, and I'm sorry if I'm churning along here. I want to make sure I have a chance to show a couple of things here. Is we have the pipeline set up. So now that when a pull request is opened against the develop branch, our Circle CI workflow will run again. You can see the checks happening live in GitHub. But in this case, in the interest of time, instead of waiting for the checks, what I'm going to do is I'm going to merge the change. Actually, yeah, from 0 to 4 to 025. So that's actually going to fix that one particular vulnerability in the application. I'm going to crush that branch, and what that'll do is it's going to run my Circle CI workflow with the code change that I just applied. So what's going to happen as this runs? Snyk has an orb for Circle CI. An orb is just a way to easily program jobs into a Circle CI workflow. It's a configuration of commands, and adding the Snyk orb to the Circle CI workflow just adds the Snyk CLI effectively to the workflow. So what's happening here is that we checked in the change, Circle CI picked it up, it rescanned it, and it said, okay, things are good. Which, just to show you, while it finishes running, you do have the ability to add to the Snyk job in the Circle CI workflow. You do have the ability to add a severe, like if you want it to fail in case you have any issues. This is what we were talking about building agreement between security and operations. An operations team might say, I don't want any high severity vulnerabilities. Well, you can program that into the workflow. The security team might say, I don't want any high severity vulnerabilities that have an exploit available. Great, you can program that into the workflow. These are all parameters that can be configured in the Snyk orb. And so what ends up happening is if you want a gate in your pipeline that says no defects allowed, you can do that. And that kind of helps developers figure out, my pipeline's not going to execute if I have high severity defects. You've now given them direction, right? So hopefully with that, I can see this is now building a new version of our container, which is then going to get scanned, and then we're going to deploy it, which, if the demo gods are with us, which I'm pretty sure they will be, then the exploit that I demonstrated earlier will no longer work. So this is one example. I know we're crunching it a little close on time. So while it finishes running, we'll go back to the Snyk product, and we go back to my project. So I want to also show the same thing I demonstrated with the open source components. It's the very same experience with the container vulnerabilities. So you have a Docker file. Your Docker file also has vulnerable components. So you see the same, some are introduced by the node runtime, some are introduced by the operating system. You can filter and sort the issues that are shown in the interface based on where they're introduced. And what we're trying to do different than other tools in the market, in the interest of helping developers fix issues faster, instead of having to triage these one by one, we're looking to see if there's a base image that can be upgraded to that might have less vulnerabilities out of the box. So instead of starting out with node 14.1.0 that has 877 vulnerabilities, upgrade to node 14.17, which is a minor upgrade, you can tackle 400 vulnerabilities all at once. Or a major upgrade to node 16, that's 328 vulnerabilities. A slim image that is generally smaller and leaner for running your application might have even less vulnerabilities. So you have the ability to open a pull request, which same thing that I showed you with the open source, just replaces the from statement in your Docker file with a different base image, which would then be picked up by your CI workflow, rebuild, you would run your unit functional tests against it, right? Because there's no guarantee that a new base image is going to work. So this is where test automation, continuous integration really plays an important part in this whole workflow that I'm demonstrating. So, that is something that don't know that we're going to have time to show today, Rats, but, feel free to let, either the Codurance team or the Snyk Note team, that you want to do a deeper dive demo, we got you. Couple of other things that I worked, since I talked about them in the iceberg, I have to talk about them here. Talking about the infrastructure as code manifest, developers now have to become experts in infrastructure. What we try to do is analyze, okay, these are CIS benchmarks, these are documented best practices, are you configuring your workload correctly? So what we'll do is we'll call out possible misconfigurations in your workload's template files. Are you running as root? Are you dropping capabilities? Do you have liveness probes? Are you setting CPU and memory limits so that you're not opening up to DOS attacks? These are things that need to be considered. I'm going to approve my deployment to Kubernetes now. Rodrigo, I don't know if this is something you and I talked about. When you're building a secure pipeline, a combination of automated and manual checks might be a good thing, right? Because you still want somebody to sign off on a deployment. I was planning to give us time during the demo to talk about that. I don't know if you wanted to add something about this stage in the pipeline.
No, I think that's fine. I think it really depends of usually if you want to get a fully automated pipeline, then it's probably is a point that your confidence is very high on your security and functional tests. So that's where we need to be careful sometimes on balancing a little bit how fast you want to be, your pace on deployment, the new features, and on how secure and stable they want them to be.
Mm-hmm.
And Thomas, we're probably coming up to the last few minutes now. So if you want to pull out some of the highlights for your demo, and then we can wrap up for everyone.
Yeah, for sure. So I overloaded my demo with things that I wanted to show. Rats, I shouldn't have done that. But this whole experience that I've shown you within the Snyk user interface is available within the IDE. You can get our IDE plugin that finds issues in the code, walks you through the data flow of how some of the custom code issues you're introducing, open you up to SQL injections or other things. The open source dependencies, as you saw, can be consumed in the IDE, so can the Terraform file scans. There are policies that can be set in the user interface. This is the codification of the rules agreed upon by security and operations teams. If you wanted to control the different severity levels of vulnerabilities or approve or deny certain licenses, this is how inside the product, the whole enterprise can come together and agree on what's allowed and what's not allowed, which is a critical part of the collaboration and teamwork in DevOps. Of course, there's reports that can be used, either at an organization or group level to see what is the risk exposure across all my different portfolio of applications. So, again, I loaded a little bit too much into the demo, but if you want to see more, please get in touch with Snyk, get in touch with Codurance. We're here to help guide you throughout your transformation.
I hope everyone enjoyed the demo as much as me. Thank you so much, Thomas. That was fantastic. I took loads away. And with the last minute, if Rodrigo, you could just give us a bit of a wrap up to the Codurance Snyk partnership, that'd be great.
Okay, I just want to give a kind of a brief understanding of the next steps if if somebody wants to go for implementation of DevSecOps, probably this is basically how we at Codurance are trying to help our customers. We have this kind of 4 stages on the continuous improvement cycle that we try to work with the customers. We usually do a quite quick assessment with the customers for them to understand where they are, and we get more information. There's a bit of educational exercise that as well, clarifying any questions that they may have in terms of the concepts and the application of tools and process as well. On the back of that, we try to understand what are the key pain points that the customer has, and then with that information, we try to address that through our strategic advice, where we run a prioritization exercise, trying to understand the impact and the effort to address those pain points and how to remediate that, and what kind of tools and process that we can put in place, what kind of skills that we need to develop from the people perspective as well. And also trying to identify how we would measure the improvements of those pain points, which leads to the implementation itself. So that's where we go and put our hands dirty and implement all the remediations for those pain points, and always keep in mind how we capture data through this process to understand the realization of the benefits for the customer. And at the last stage, of course, getting all these outcomes as a feedback, and then analyzing what went right, what went wrong, and how we could improve, and send information to the beginning of the next cycle when we do the assessment again, and go all over again until we keep raising the maturity of the organization on that DevSecOps without impacting too much the business and the way that you currently work.
Perfect. Thank you, Rodrigo. So that brings us to the end of the presentation. You know, there or thereabouts on timing. So thank you so much for an excellent demo. We've got some great feedback in the chat. So from Flavia, who said it was a great introduction and definitely gave me some new ideas about addressing containers. Love that there is a VS Code plugin. We'll be taking a closer look at Snyk. So that is fantastic. So thank you all. Here are some contact details, but there will be a follow-up email with the recording, with some resource links as well, so you can carry on the discussion and the research yourself. And yeah, it's been an absolute pleasure to have you with us today. Thank you so much to our excellent speakers, Thomas and Rodrigo. And I don't know about you, but it's sunny in Manchester. And for those that haven't been to Manchester, this is a very rare occasion. So wherever you are, whatever time of day it is, go and enjoy the rest of your day or your evening. And thank you again for joining us.
Thank you very much, everybody.